Have you observed the temperature difference of the sand and the water at the end of a hot summer day at the beach? The sand has become quite hot. The water has stayed cool, right? Why on the same day are the temperatures of water and sand different? Specific heat is the key. Different materials would warm up at different rates because each material has its own specific heat capacity. Transferring the same amount of energy by heating into some materials gives a bigger temperature rise than in other materials. Specific heat capacity refers to the amount of heat required to cause a unit of mass in grams or a kilogram to change its temperature by 1 degree Celsius. Specific heat capacity provides a means of mathematically relating the amount of thermal energy gained or lost by a sample of any substance to the sample's mass and its resulting temperature change. The relationship between these four quantities is expressed in the equation Q is equal to M times C times delta T, or Q is equal to MCAT to remember the equation easily. Q is the quantity of heat transferred to or from the object, M is the mass of the object, C is the specific heat capacity of the material the object is composed of, and delta T is the resulting temperature change of the object. In the SI system, specific heat is measured in joule per kilogram Kelvin. Non-SI units of specific heat are joule per gram Kelvin, joule per gram degree Celsius, and joule per kilogram degree Celsius. The size of a Celsius degree and a Kelvin are exactly the same, and therefore delta T is the same whether measured in Celsius or Kelvin. A delta value for any quantity is calculated by subtracting the initial value of the quantity from the final value of the quantity. In this case, delta T is equal to T final minus T initial. A 0.025 kg metal ball is heated to 200 degrees Celsius with 2330 joules of energy. What is the specific heat in joule per gram degree Celsius of the metal? Let us list the information we know. M is equal to 0.025 kilograms. Delta T is equal to 200 degrees Celsius. Q is equal to 2330 joules. Since the given is 0.025 kilograms and the required unit is in joule per gram degree Celsius, we will convert kilograms into grams. 1 kilogram is equal to 1000 grams. Cancel kilograms and multiply 0.025 and 1000, and that is now 25 grams. Let us now place the given into the specific heat equation Q is equal to MCAT. 2330 joules is equal to 25 grams times C times 200 degrees Celsius. Multiply 25 grams and 200 degrees Celsius, and that is 5000 grams degrees Celsius. To get the value of C, divide both sides by 5000 grams degrees Celsius. 2330 joules divided by 5000 grams degrees Celsius is equal to 0.466 joules per gram degrees Celsius. The specific heat of the metal is 0.466 joules per gram degrees Celsius. A 0.5 kg block of zinc with a specific heat of 388 joule per kilogram Kelvin is heated from 295 Kelvin to 350 Kelvin. How much heat was absorbed by the block of zinc? The first thing that we have to do is to list the information we know. Mass is equal to 0.5 kilograms. Specific heat is 388 joule per kilogram Kelvin. Delta T is equal to the difference of 350 Kelvin and 295 Kelvin, and that is 55 Kelvin. Plugging these values into the specific heat equation Q is equal to MCAT gives us 0.5 kg times 388 joule per kilogram Kelvin times 55 Kelvin. Since we are given a mass in kilogram, temperature in Kelvin, and specific heat in joule per kilogram Kelvin, this allows us to cancel units of kilograms and Kelvin. The unit left is joule. Getting their product, it gives us 10,670 joule.